Hello there. So this is going to be a video talking you through how to answer questions which need a compass and protractor. For example, constructing shapes with a ruler or bisecting angles. So the general term for these questions is constructions and loci. So to do these questions you will actually need the worksheet, which I can't physically give to you through a computer or phone on YouTube. So in order to get that yourself, I've included the link here. So if you follow this link and download, it will be able to be printed off, and then you can actually have a go at the questions yourself physically and use this video as a guide for the questions you've attempted. And I've also included this link in the video description on YouTube, so you can click through there on your mouse or smartphone and download to your device. So you will need to actually have a worksheet in front of you to get the full benefit from this video. But having said that, we'll make a start and we'll talk through the first few questions, which are to construct the perpendicular bisector of a line. So this is part A, to construct the perpendicular bisectors of these 6 lines. So what we need to do is leave the compass and pencil marks on the diagram. So by leaving the compass marks and the pencil marks, it gives the examiner proof that you've not just measured with a protractor and had completely avoided using your compass. So what we need to do is to get one of these things, which is a compass, and the perpendicular bisector, by the way, tells us the distance and location of all points that are equally spaced apart from 2 points. So the perpendicular bisector tells us, for a line, the points which are all equal distance from either end of the line. Now the way we do this is we put the compass needle on one end of the line here and make sure the compass width is at least 2/3 or so, about 2/3 or 3/4 along the length of the line. Once you've done that, we get the compass and do a big curve going above and below the line, like so. Then I'm going to swap the compass needle over to the other end, and we're going to do the same thing from the exact opposite end of the line. And what should happen is the 2 curves cross at 2 points above and below the line. And what we're going to do is, with a ruler, we're going to draw a straight line through these points like this. And when we do that, that's our perpendicular bisector. So that red line is our final answer. Question 2, let's do the perpendicular bisector of this line now. So compass needle at one end of the line, a curve above and below the line. We're going to swap the compass over, do the same thing from the other end of the line, like so. Where the 2 points, where the 2 curves, cross, we're going to get a straight edge and do a straight line in between these 2 points like so. And that's the perpendicular bisector for question 2. Question 3, to do the perpendicular bisector of this line, compass needle at one end, the big curve above and below. Same thing from the opposite end of the line at the bottom. Again, a big curve above and below. Now when doing these, it's important not to alter the width of your compass. Keep the compass width the same. Don't do this, don't make it any narrower or longer halfway through the question. Keep the compass width the same. Then what we do is a straight line, again, through where these curves have crossed above and below the line. And that red line is the perpendicular bisector. Question 4. Same deal. Compass needle at one end of the line, a big curve above and below. Switch to the opposite end of the line. Keep the compass width the same, and a big curve above and below this one. Move the compass away, get the ruler out, and do a straight line going through both the top and the bottom of these curves. and that's for perpendicular bisector, this red line. So this will be a 90-degree angle here, and here, of course. Question 5. Again, we're going to do the same thing yet again. So compass needle at one end of the line, do a big semicircular curve from one end, switch sides, compass needle at the other end, and a big semicircular curve at the other end of the line. So these curves cross at 2 points, and where they cross, do a straight line through where they cross, and once again that's how you do your perpendicular bisector. Final one, question 6. So we're going to take the compass needle, put it on one end of the line, and do a semicircular curve going like this. Then we're going to do exactly the same thing from the other end of the line, like so. Where they've crossed over, we're going to just get a ruler and join in the points that go through. And so that's a quick run through of how we do the perpendicular bisector of a line. So part B is a bit different to part A, but it's very similar as well at the same time. We're going to be constructing a perpendicular bisector through a given point on a line. So not a perpendicular bisector from end to end, but for a particular point which has been given to us. So for example, for this one here, we need to construct a perpendicular bisector to AB, but it has to go through point P here. So what we need to do for this one, first of all, is we get our compass and put the needle directly on the point through which we want the bisector to go through. Then we just narrow in the compass width so that it's able to touch both ends of the line, both here and at the other side. So keeping the compass width the same, we're going to do a little curve going through one end of the line, switch over, keeping the compass width the same, but still keeping the needle on the point P, and do another curve there. So now what we're going to do is just focus on this bit of the line, and we're going to do the perpendicular bisector of just the line segment between the bits of the line that this curve has touched. So now what we're going to do is get the compass again, and this time we're going to put the needle of the compass where the curve has been crossed here. Get the compass needle on that point and make the width of the compass about 3/4 of the way along from one point on the line where the curve cuts the line to the other point where the curves cut the line on the other side. So about 2/3 or 3/4, but definitely more than halfway. It needs to go beyond point P. Then it becomes very similar to what we've done before. So a big semicircular curve from one end of the line, switch it over to the other side, over here, keeping the compass width exactly the same, and then a big curve from top and bottom through that point as well. Move the compass needle away. Now we need our ruler, and we're going to do a straight line through both points here where the curves cross each other. And what we'll find is we'll have a perpendicular bisector that goes through both curve crossings, and it will cut straight through P. And so it's a perpendicular bisector that passes through point P for that one. Question 2, we've got a similar idea to question 1. However, it's a slightly diagonal line, but I'm going to show you how it's still exactly the same idea. So we get the compass, we put it on the point which we want to do the bisector through, and make the compass width such that the compass, if we do a curve, would cut both ends of the line either side of P. So it'll cut here, and it'll cut just there before the end of the line. And so we're going to make a little cut here, and we're going to switch the compass needle over, keeping the width of the compass the same, and do a little cut there. Then what we're going to do is now we widen the compass width for this stage, widen it once and then keep it the same. So the width of the compass becomes about 3/4 of the way along from one bit where the line's cut to the other bit where the line's cut. We're now going to do a semicircular curve from one end, where one curve cuts the line. Then we're going to repeat the process at the other side, where the other curve cut the line. Having done that, we're going to get a ruler and do a straight line through both bits here, where the curves have crossed each other. And again, what we'll find is we've done a perpendicular bisector going through point P, which was what we wanted to do. Question 3. What we need to do now is a perpendicular bisector of this line given, but it needs to go through the end of the line at point D. And so we've got no space at the end of this line. The compass, if we do a curve at this end, it's going to hit nothing. So what we do in this example is we take the line which has already been given to us and we extend it going a bit further along. Like this. So we just extend the line going a bit further. Secondly, now we've done that, we get the compass as usual and we put it at the end of the line which we want the bisector to go through. So we want the bisector to go through D. And so what we're going to do is to do a cut, a curve, going through where we extended the line, and the same at the other end of the line, keeping the compass width the same. Now what we're going to do is put the compass needle on top of where the curve cut the extended line, widen the width to about 3/4 of the way between where the curve cut one end and the curve cut the other end of the original line, and do the same idea as what we did before. A big curve above the end of the initial line, swap sides, and a big curve at the end where the curve cut the other bit of the line. So now the curves are cut each other twice, above and below. Now the final step is to get a ruler and to draw in a straight line through both parts where the curves have crossed each other, like so. And what you can hopefully see is we've now made a perpendicular point here. Put that to be a right angle. In fact, I'll just draw it on, why not? That's a right angle. And it's gone straight through the end of the first line we had. It's gone through D and it's perpendicular to the line CD. Question 4 is a rarity. I don't think in person it's going to be likely you'll see this on your foundation tier paper, but if it ever does, I'm going to give you an example so you know how to do it. Construct a perpendicular to line MN. I'll just label that here. So that's M and this is N. And it's going to pass through the cross labelled P. So what we need to do for this one is we put the compass needle first of all on this point above the line. We need to get the compass width so that if we were to make a curve through line MN, it would cut at both points, at 2 points. So it cuts at one point and cuts at the other. So we need it just wide enough so it'll cut at 2 points. So it'll cut here, carry on. It's missing M there, so get it a bit narrower. And that should do the trick. So if I was to do a curve starting with the compass needle at P, it would cut M and then cut further down the line here. And so we'd set the compass width to a point where the line's going to be cut in 2 places. So we've got one at N and a cut at the end at M. Well, not at N, sorry, but closer to the line N. Now what we can do is we can keep the width of the compass the same, And based on that, what we can do next is we're going to put the compass needle at one point where the curve's crossed the line. So if we put the compass needle here to begin with, now what we're going to do is just a curve below only the line MN from one end. We now do the same from the other end where the first curve cut our starting line. Put the needle here and do the same thing, a curve going below the line, like so. And what we'll find there is that the two curves have crossed below the line, so we've got a cross here, and we had our initial cross at P. Finally, we just use a ruler and do a straight line going through P, going through where the curves we've just drawn have crossed as well. And by doing that, what we will have done is made a perpendicular to the line MN that goes through point P and carries on through the other side. So if that were to be measured, this angle here would again be 90 degrees. And so that's part B finished off. Part C, I'm going to show you how to construct the angle bisector for any angle. So the angle bisector, what this does is it takes an angle and splits it in half, splits it into two equal bits. And so, for example, if you had a 50-degree angle and you bisected it, you'd end up with two 25-degree angles. So when we were doing the perpendicular bisector, I did mention that the reason we'd do that is if you wanted to know a line which was an equal distance from 2 points. The angle bisector is what you do if you want to find a line that's an equal distance from 2 sides. So if it's an equal distance from 2 sides, it's an angle bisector. If you want the equal distance between 2 points, it's the perpendicular bisector. And so what you do to do the angle bisector is, first of all, you put the point of the compass at the point of where your angle starts. Then get the compass width so it's about halfway along the lengths of the sides of the angle, and just do a curve that cuts both bits of the angle, 1 and 2. Then what we do is we move the compass needle to where the first bit of the curve cut the line, and do a circular curve in the middle of the angle. We then do the same thing at the other bit of where the curve cuts the other line. So move the compass needle down to the other part and do a curve from the other end going inwards, like so. And what you need to happen is for these curves to cross. And where the curves cross is where we're going to join a line from where the angle starts through the crossing part. And if we do that, what we've made is the angle bisector. So that's how you split the angle in half. So I'm going to show you now how to do that for a few other examples, just so you got a really good grounding of how to do this. So question 2, the angle bisector for this one. We put the compass needle where the angle begins, do a curve that cuts the angle at the 2 lines of the angle, keep the compass width the same, put the needle on the first part where the curve cuts the first line, do a curve in the middle of the angle, switch the compass needle over to this part at the other end of the angle and do the same process. So the curves cross. Then when the curves cross, a straight line through where the angle begins, through the crossing part, and that's the angle bisector for 2. Question 3. So once again, we're going to put the needle where the angle begins, like so. Cut the angle at the top and bottom edge. Move the compass needle to where the curve cuts the top edge, and do a curve in the middle of the angle. Move the needle down to where the curve cuts the bottom edge, and do the same. Keeping the compass width the same, of course. And where they cross, a straight line from where the angle begins through where the curves cross, and that's the angle bisector for question 3. Question 4, put the compass needle where the angle begins, cut the curve on the top edge, cut the line at the top and bottom, move the compass needle to where the curve cuts the top line, and do a curve in the middle of the angle. Then move it to the other side and do a curve from the other end so that the curves cross in the middle. And finally, with a ruler, draw a straight line from where the angle begins through where the curves crossed, and that's the angle bisector for question 4. Question 5, put the needle where the angle begins, do a big curve from one end to the other of the angle. Now, where the curve cut the line at one end, we're going to do another curve towards the middle of the angle like so. Then move the compass needle to the other end, and we're going to do a curve from there as well. So it'll again cross in the middle. Now, where these curves cross, we're going to do a straight line yet again from where the angle begins through where these points crossed, and that's the angle bisector for question 5. Question 6. So again, put the needle where the angle begins, and we're going to do a curve that cuts the angle at both points, and then compass needle at one end of the line, going to do a curve towards the middle of the angle, move the compass needle to the other end, and do the same thing here. Now, if they don't cross, like mine aren't here, which is a bit of a shame, it's not this big one that needs to cross, it's the other two. So this blue one needs to cross with this other blue one. If this ever happens, don't worry, it's good in a way I've made this mistake. Just go back to the other point and extend that line a bit further on, like so. Now, that's just a freak chance, that very rarely happens. So they've crossed at 3 points, but that's just a complete coincidence, don't read too much into that. The main thing is, this curve and that curve have crossed here, and so from where the angle begins, just do a straight line outwards, and that's the angle bisected. Question 7, again the same idea. Whoops, compass has disappeared. So put the compass needle at one end of the line here, cut the curve in both places, move the compass needle to one end of the line here, where it's cut, and do a big semicircular curve in between the lines. Switch over to the other side, and do the same from the other side of the angle, going inwards. Always keeping the compass width the same. Then where they've crossed, do a straight line from where the angle begins with a ruler, through the crossing part, and yet again we've bisected the angle for question 7. Question 8. So we're going to put the compass where the angle begins, a big curve that cuts the angle both lines, then moving down to where the compass cuts one line, we're going to do a curve like so, and then the same at the other end here. And so the curve's cut at both ends, across here. And so the final thing is to do a straight line from where the angle begins, through where they've crossed, and that's the final angle bisected for question 8. Part D of these questions, we're going to have a look at some past exam paper questions that have actually happened in previous exam papers, just on constructions first of all. So it's going to be a mixture of what we've done in parts A, B and C. So part 1 of this, well, question 1 of this section, we're going to construct the bisector of this angle. It says you must show your construction lines. So all that means is, once you've done the question, don't rub out with a rubber the lines you've drawn with your compass. Leave those on, because they'll help you to pick up some marks. So like before, to do the angle bisector, rather, we put the compass needle at the beginning of the angle. Now, keeping the compass width the same, we do a curve that cuts the line above and at the bottom. We then move the compass needle to where the first bit of the curve cut the top edge of the angle, and do another curve in between the lines. Then move the compass needle to the bottom line where the curve cuts it, and do another curve going upwards that joins and crosses the other curve. Finally, we're going to do a straight line through where the angle begins, through where the curve's crossed, and that's the angle bisector of the question done. So that's 2 marks. So question 2, we have here a triangle which is ABC, and we're given some measurements for this triangle. And so AB is 8 centimeters, AC is 6 centimeters, and BC is 10 centimeters. We need to do an accurate drawing of the triangle and use construction lines. So we can't just use a protractor or just guess where these points are going to go. So what we do need is a ruler, first of all. So if I just change this scale to centimeters, because all these are whole numbers of centimeters, you should find on your worksheet that BC has been done for you accurately as 10 centimeters, as you can see. But the point A is 8 centimeters from B, and so what we're going to do is set our compass width to 8 centimeters, like so, and we're now going to measure by putting on the compass needle at B. I'm going to draw in all the points which are exactly 8 centimeters away from B. So all the points 8 centimeters away from B will be on this blue line here. However, point A is also 6 centimeters away from point C. And so what we can do next is change the compass width to 6 centimeters. Then put the needle up C. I'll just flip it over. And do exactly the same deal from the end of the line at point C. Like so. And so point A, by the definition of it, is going to be both 8 centimeters from B and 6 centimeters from C. And so this curve here, starting at the top and going down, is the location of all points 8 centimeters from B. This one here, this curve, is the points which are all 6 centimeters from C. Where these cross will be where point A must be. And so finally, where they cross, we're going to do a line from B through to where this crosses here. Just move it up slightly. And the same again at C. Like so. And so where these two curves cross, we can label that C. And then we've essentially done the question. If you measure it, you should find that this is 8 centimeters, and that's 6 centimeters. So you can prove it by measuring it yourself. So, for example, if I just get this rule here, You can see that's 8. The other side will be 6 as well, but you can check that one for yourself. Question 3, again we need to do a angle bisector. So this is similar to what we did in section C of a worksheet. So what we're going to do is get the compass here, put the needle at where the angle begins. We're going to do a curve which cuts the top edge of the angle. In fact, we'll get that a bit smaller, I think. Okay, so yeah, we're going to do a cut here at the top of the angle line and carry it on to the bottom of the angle line too. Then we're going to move the needle to where the curve cuts the top angle line and do a curve going inwards like so. And the same over here like this. And a curve from the other end so that the two curves cross over. And where these curves cross, we're going to get a ruler and do a straight line from where the angle begins through where the points cross, and that is the angle bisector of PQR completed. So now PQR, that angle's been halved by this red line. Question 4, we've got here a rhombus. So the thing with a rhombus is that all sides are going to be the same length. So that's one thing we need to know for a rhombus. So based on that fact, that will help us to deal with lines DC and BC, because these lines here will be 7 centimeters each. However, we're told that the line from D to B is 6 centimeters, and so we're also told that point D here is 7 centimeters from A, as well as being 6 centimeters from point B. So using this fact, what we can do is get a ruler and measure out 7 centimeters from A. So it's going to be the same width as the line length. It's going to be 7 centimeters, just like this line AB is, because it's been drawn accurately. So with compass needle at point A, what we're going to do is do a curve going up above B and carried on, like so. And then we're going to go to B and measure a compass width of 6 centimeters and do the same process at the other end of the line at B. So measure 6 centimeters width, like that. Switch the compass over. Oops, made it disappear, which is never a good idea. Yeah, so we've got it here, measure 6 centimeters. Put it at end B, and then do a curve from B that cuts the first curve. Now where these two curves cross will be where it's 7 centimeters from A and also 6 centimeters from B. And so what we found here is actually going to be point D. And so if we just make a little mark here, just to show we've worked out where point D is, point D will be here, that point. Now what we can do is draw a straight line from that point to A, and as well from that point to B. And so that's the line which is 6 centimeters long. We've just done that one here. Now the next line, DC, is straight across and is going to be 7 centimeters long. But the line BC is also going to be 7 centimeters away from B. So again, using a compass we can measure this out without having to rely on just a ruler. So if we just get the compass and measure out a width of the compass of 7 centimeters, like so. We've just worked out point D, so point D is this one here. what we're wanting next is to find point C. And so we're going to put the compass needle at point D and do a curve like this, and do the same at B, so that the two curves cross. Now where these curves cross, that will be where point C is. And so move the compass away. The compass has done the hard work for us now. So we can now label this C. This point here is my C. Now with a ruler, we're going to draw a line across to B, sorry, across to D rather, and then also across to B. And having done that, we've actually constructed the rhombus as we needed to. Leave these blue curves on there, because they're needed as proof that you've used a compass correctly, and that's question 4 done. Question 5, we're told here we need to construct an equilateral triangle with sides of length 6 centimeters. So if you were to just check on your diagram in front of you, you should find that this line is 6 centimeters long. So what we're going to do is set our compass to be the same width as this starting line. So maybe slightly longer, like so. Then from one end of the line, we're just going to do a big curve that goes above and below, like so. Then we're going to swap over to the other side of the line, which is here, and we're going to do exactly the same thing from the other end. So it looks like some sort of tent or teepee or something, some wigwam. I don't know, I'm not very cultured, sadly. But where these 2 points cross, this will be the point which is both 6 centimeters from this point here and 6 centimeters from this point here. And so that's going to be the third point of the triangle we need to draw. So I'm just going to put a little dot just to denote we found the point we need, which is here. Then from that point, we just do a straight line to where the angle begun here, and another straight line going down to the end of the line at the other side. And that there should be an equilateral triangle. Now the upshot of constructing an equilateral triangle is, another way of thinking about it is, you've created a 60-degree angle, because each angle inside an equilateral triangle is 60 degrees. So in terms of why I'm mentioning that, it's going to make some more sense soon. So that'll be 60. This one here will be 60. You don't need to draw these angles on yourself, by the way. Constructing the triangle's enough. It doesn't actually to construct it and also label the angles. This is just to show you something. So you've made 3 60-degree angles, and if you don't believe me, you could also just actually show this using a protractor. So using this protractor, you can see here, hopefully, that the 60-degree point is directly on top of this red line. So we have made a 60-degree angle. I'll come back to that in another question. Question 6, we need to make a 30-degree angle at P. So if you just watched what I said in question 5, where we did the equilateral triangle, to construct an equilateral triangle, by definition, you're making a 60-degree angle, because each angle in an equilateral triangle is 60 degrees. And so what we can do here is do a 60-degree angle, and then bisect that angle. If we do the angle bisector of 60 degrees, we'll half it and make a 30-degree angle. And so step 1 for this one is we're going to make ourselves an equilateral triangle. So we're going to put the point of compass at point P, widen it to the end of the line, then do a curve going up and over. Now we're going to do the same from the other end of the line, like so, so that these two curves cross over. So where they've crossed over, we're now going to do with a ruler. We're going to join these up to either end of the initial line we had. And by doing that, we've made a 60-degree angle. So that's 60 here. If you want to, you could do it on the other side as well, but you wouldn't really need to. So just for the fact you wouldn't need to, I'm just going to do that in a dotted line. So you could if you wanted, but you don't really need to. You just want one 60-degree angle, really. So now this is 60, what we can do is think about bisecting this angle to make a 30-degree angle. So we're going to get our compass back in, put it on point P, because this is where we want our 30-degree angle to be. Make the compass slightly narrower. Now, keeping the compass width the same, I'm going to cut both sides of the angle, move the compass needle to where the curve cut the top side of the angle, and then do a big curve in between the angle sides. Move the compass needle to the bottom edge of the angle, and do the same from that side, so that the two curves now cross over here. Now where these two curves cross, we're just going to get a ruler and do a straight line through where the angle begins, here at point P, through where these 2 points have crossed here. So that green line is a 30-degree angle. The angle between this horizontal line and the green one will be exactly 30 degrees. So 2 steps of that one. To make a 30-degree angle, you'd construct a 60-degree angle in the same way you'd do an equilateral triangle, and then bisect 60 degrees to get 30 degrees. The final part to part D is question 7. We're going to construct a 45-degree angle at A. Now in the same way that a 30-degree angle is a way of bisecting a 60-degree angle, a 45-degree angle we can make by bisecting a 90-degree angle. And so to make a 90-degree angle, that's the same as doing the perpendicular bisector. And so we're going to do a perpendicular bisector going through A. And so for this, what we're going to do is we're going to start off the line here and extend it so it goes further back, like so. So just an extended line further back from A. And now what we're going to do is we're going to do an angle bisector going through A. So we get the compass. Just going to flip it over slightly. We're now going to put the compass on point A. Then I'm going to do a line here. Keep the compass up the same, and do the same on the other side. Another line here. Now we move the compass needle to where the first curve cut the line. Now we're going to widen the compass, so it's about 3/4 of the way in between these two little curves. Now we're going to do a curve going above and below the line like this. Switch to the other side. Again, I've lost my compass. Keep doing that, which is no good. Let's get to the same width, just bear with me. There we go. And yes, do the same at the other side. Okay, sadly that's just gone off the page, but hopefully you'll be able to trust me on this one. So we're going to do a straight line going through where both points cross over, like so. And so that's now a 90-degree angle at A. Now what we're going to need to do is to bisect that 90-degree angle to make the 45-degree one we need to. And so now we're going to put the compass needle back at A. Make it slightly narrower. And then from A, just going to do a big curve that cuts both lines of a 90-degree angle, like so. And then from there, from where the curve cuts the top line, we're going to do another curve going towards the middle. And we're going to do the same again at the other side where the curve cut the bottom edge of the angle, the 90-degree angle. So again, they need to cross over like this. Now once they've crossed over, the next thing we do, and the final thing, is to do a straight line from A, going through where these points cross. And so this angle here will be a 45-degree angle, and therefore we've done a 45-degree angle. Basically we just bisect the perpendicular bisector. Do a 90-degree angle first, and then bisect it after. Part E is looking at past paper exam questions about loci, which just means the locations of certain points we want to find. So it's very similar to constructions, but apart from making shapes or drawing things, we're going to be drawing in the locations of possible things. So for part 1A, question 1A, we need to draw the locus of all points which are equidistant from points A and B. Equidistant just means equal distance. So if we want the location of points an equal distance from A and B, that's the perpendicular bisector, because a perpendicular bisector will show us the location of the line which is an equal distance from 2 points. If you want the line which is an equal distance from 2 sides, that's the angle bisector. In this case, the line that's equal distance from 2 points is the perpendicular bisector. So as a suggestion, first of all, what we could do is we could draw an imaginary line with a ruler going between A and B. Now this isn't what you'd have to do, it's just a suggestion, just to remind you that you're going to be doing the perpendicular bisector of this line, in effect. And then from one end of the line, so for example from A, we're going to put our compass needle on A, make sure the compass width is more than halfway along the line, and we're going to do a semicircular curve above and below the line. We're going to move the compass needle to the other side where B is, and do the same at B. So the curves cross at 2 distinct points. Now where these curves cross, we're going to do a straight line going down between them. And that red line is the perpendicular bisector of the line A and B, but more importantly, it's also, according to the question, the locus, the location, of all points which are equidistant from points A and B. And so that's part 1A done. Now for part B, we need to draw the location, locus just means location, of all points that are exactly 3 centimeters from the line PQ. And so what we'll need for this one is a ruler, and we're going to need to measure 3 centimeters width on our compass. So let's get our compass here and measure a width of 3 centimeters along it. So there we go. And from one end of the line, what we're going to do is put the compass needle at P and just draw a circle around P. So that circle is all the points that are 3 centimeters from point P. If we do the same at the other end, at point Q, do a circle which shows all the points that are 3 centimeters away from Q. Now in terms of all the points that are 3 centimeters away from the line PQ, what we need to do is use a ruler and do a straight line that just scrapes the top edges of these circles. So what we need to do now is to get our ruler and just keep going until it just scrapes the circles like this. And draw a line in from one point on the circle to the other, like so. And go above with ruler and do the same so we get to where it just scrapes the top edges of both circles. We're basically finding a tangent, in a way, at the top points of both circles. So having done that, we are nearly done, but not quite done. What we need to do is get rid of these lines in the inside of this running track sort of shape. We need to get rid of these bits of the circles. And the way we're going to do that is just to use our rubber and just to erase them. So we're just going to rub off these points here. So using a pencil end rubber or such like, we're going to just go in and erase these points. So what we need to do here is erase these bits. So, oops, not that one, but all the way along here as best we can. Oops, couldn't do that bit. It's hard to see where I'm going. I do apologise if it's taking a bit longer. It's quite hard to see whereabouts it is. In real life it's actually much easier. So there we go. I'm just going to put back on the bits of the line PQ we want to actually keep. And so there we go. So that blue line along the outside is essentially the distance of all points exactly 3 centimeters from the line PQ. And so above PQ and below is going to be a straight line and circular edges around the ends of the line. And so that's question 1 done. Question 2, we have a map, a scale map, and we've got a ship drawn on the map, which is given by point S. And point C here is a point on the coast. So ships must not sail closer than 500 meters to point C, and the ship sails on a bearing of 37 degrees. So this isn't really a walkthrough of bearings, but just to quickly mention, because we'll need to know this bearing, we need to get our protractor to hand. We need to have it facing straight up, parallel to this north line. So we need to then put the compass on top of S to measure for 37 degrees. And the 37 degree angle, just get the compass out of the way, we count from north until we get to 37. So 10, 20, 30, 35, that's 36, 37's here. And so what we're going to do is just mark on 37, which should be at this point here. Oops, not that one, that was 36, 37's there. So now we're done with the compass, so the protractor we can remove it, and then with a straight line, what we're going to do is just draw on that bearing of 37 degrees, like so. And so what we've done here is a 37 degree angle. So the ship will be sailing up and down this line. It next says about the ship not sailing closer than 500 meters to point C. Now that can be worked out. So what does 500 centimetres look like on our diagram? Well, this is where we need to use the scale. So if we have a look at the scale of this drawing, we've got here that 1 centimetre represents 100 metres. So if we could just write this in, that 1 centimetre represents 100 metres. So 2 centimetres would be 200 metres, 3 centimetres would be 300, and so on. Basically what I'm getting at is that we'd need 5 centimetres to measure, to represent 500 metres. And so because we're told in real life that the distance is at the 500 metres, the ship can't sail any closer than 500 metres to point C, on the actual map that will be represented by 5 centimetres. So on the map we can't go within 5 centimetres from point C. And so what we need to do for that is measure out a width of 5 centimetres on our compass, like so, and then we put the compass needle at C, like this, and just do a curve, a circular curve all around point C, like so. And so the question here is, will the ship sail closer than 500 metres to point C? And we need to explain our answer. And so what we've actually got here is, here we're not close to point C, but then this line does actually go inside this forbidden circle. So the line goes inside the circle, and between here and here it is actually closer than 500 metres to point C. And so this yellow bit here I've just coloured in represents the region which is too close to point C. And so in terms of actually answering the question given on this exam, will the ship sail closer, ends up being a yes or no type question. So you need to just conclude with yes. It will. Sail closer than 500 centimetres from C. And that's the final concluding main point. Question 3. ABC is a triangle, and we need to shade the region inside the triangle that's both less than 4 centimetres from point B and closer to the line AC than the line AB. Ooh, so this is going to be a bit challenging perhaps. It sounds it, but actually it's not as bad as what it looks. So, less than 4 centimetres from point B, what we need to do is to get a compass, set the compass width to 4 centimetres. And then from point B, we get this compass needle, put it on top of B, and then do a a bit less than a semicircle, a curve that goes from one end of the triangle edge to the other. That blue curve represents the points that are exactly 4 centimetres from point B. Next it says it needs to be closer to the line AC than the line AB. And so first of all, you need to work out the line which is exactly the same distance from AC and AB. And the way we'd do that would be to do the perpendicular bisector. Sorry, my mistake. The angle bisector is what I mean to say. The angle bisector tells us the location of points that are an equal distance from two sides. So what we need to do next is the angle bisector of the angle BAC, because A joins the lines BA and AC together. And so we put the compass needle at point A and do a curve that crosses both AB and AC. Then from one line that's been crossed, we do a little curve like so, in between AB and AC, that goes through the middle-ish of AB and where AC would go. Move the compass needle over to the other edge, and do the same, so that we have two crossing curves. The next step, between where the curves cross and angle A begins, we do a straight line through both. And that straight line is the angle bisector. So now it's just a case of piecing these two bits of information together. So we want the region which is less than 4 centimeters from B, so within this bit of the diagram here, but also it needs to be closer to AC, so it needs to be on this side of the red line. And so the bit of the diagram that satisfies both these points, whoops, that didn't work very well, did it? So I'll have to just colour it in manually. So the bit we're after is these points here, which I'm just going to show you by colouring in. It's a bit of that curve that's trapped in between the curve itself and the red line. I've gone over the line slightly there, but it doesn't need to be absolutely perfect, just as well as you possibly can. So it's as clear to the examiner as you possibly can be, to minimise the chance that you're going to get unfairly or harshly marked down. So it's those points there, it's that red region I've just coloured in for you. Question 4 is a plan of the park. We're given a scale again that 1 centimetre represents 100 metres in real life. A fountain in the park is equidistant from A and C. The fountain is exactly 700 metres from D. So because it's exactly 700 metres from D, what we're going to do here is we're going to draw in 700 metre width on using the compass. So 700 metres, using this scale here, if 1 centimetre is 100 metres, then we'll need 7 centimetres to represent 700 metres. So we're going to set our compass to a width of 7. In fact, I'll just write that in for you so it's a bit clearer. So if 1 centimetre is 100, then what that implies is that 7 centimetres represents 700. Okay. So now that we've done that and measured out 7 centimetres, we get the compass needle, pop it on top of point D, and do a curve which is cutting the lines at all points, like so. We're also told that the park wants to have a fountain which is an equal distance from points A and C. Now, to do a line which is equal distance from 2 points, what we need there is the perpendicular bisector of the line between those points. So between A and C, these two lines here, we want to work out the perpendicular bisector of those two lines, of that one line, sorry. So to do that, what we're going to do is we're going to get the compass needle, pop it on top of A, do a big curve above and below A, like this. Switch the compass to the other side, pop it on top of where C is, and do a curve above and below where we have C. The final step is, with a ruler, to do a straight line through where both of these curves have just crossed over each other. So what we've got here is the perpendicular bisector of the line AC. That red line in solid fill is the distance which is the point which is at an equal distance from A and C. So we want it to be exactly 700 meters from point D, as well as this fact. So exactly 700 meters from point D was this red curve. The point which is an equal distance from A and C is this red curve. So it's where the black curves and red curves cross over. We need to mark the fountain with an X. And so the fountain needs to go here. We're going to mark that with a nice big clear X. That's where the fountain would need to go, where the two lines, the black and the red, cross. Question 5. This was a 6-mark question, which is almost unheard of now. So if you can do this question, you can more or less do any question. So let's have a look at this one. So Derek is planting a tree. The tree needs to be more than 5 meters from the back of the house. So more than 5 meters from the back of the house is what he's saying. We need to know the scale of this diagram. So this diagram has a scale that 1 centimeter is worth 1 meter. And so in our case, 5 meters, that'll be represented by 5 centimeters. Later on it says about 8 meters, so we may as well convert this into what it is on our diagram. 8 meters will be represented by 8 centimeters. But first of all, the tree has to be more than 5 meters from the back of the house. So where's the back of the house on this diagram? It's this bottom line. So it needs to be further than 5 centimeters away from this line. And so what I'd suggest you do is to get a ruler, mark on where 5 centimeters is, putting the 0 line where the back of the house actually is, and measuring straight up. So just mark on 5 centimeters at one end, move along to the other side, keeping your ruler nice and vertical. And measure 5 centimeters at the other end too. After doing that, what we're going to do is, let's get this rule out of the way for a second, and down you go. Right, I'm going to join up a line from that one to that one with a ruler. A straight line going through both points. And so, because we're told that the tree's got to be more than 5 centimeters away from the back of the house, it's got to be up here in this region. It can't be anywhere in here. So this region here is just a big fat just no. You can't put it in here. So the next thing is, it's got to be nearer to the left-hand fence than the back fence. So the left-hand fence is this left side, the back fence is the top side. So if we're talking about distances between two sides, that's going to be a case of having to do the angle bisector of the point where the two sides join. So what we're going to do for this is the angle bisector of this corner at the top here. So we're going to get our compass, and we're going to put it on top of where this angle begins, like that. Then I'm going to do a curve that cuts the left-hand fence and the back fence. After doing that, where the curve cuts each line, we're going to put the needle there and do a curve going inwards, and the same from the other end, a curve going inwards from there, like so. Finally, using a ruler, we're going to do a straight line from where the back fence and the left-hand fence joined, we go straight through where the curves crossed and that point. And so we've done now the angle bisector of the corner where these two fences, the back fence and the left-hand fence, join. So we need it to be nearer the left-hand fence than the back fence, and so we want the region to be this side here rather than this side over here. So we want it to be on the left-hand side of this red line. Finally though, we are told that we want it also, this tree, to be less than 8 meters from the back right-hand corner of the garden. So 8 meters, we need to measure out 8 centimeters, don't we? And from the back right-hand corner, we're now going to put the compass needle from that back right-hand corner and do a curve, a circular curve, from that back right-hand corner that crosses all lines here, like so. So, that's a messy looking diagram, so we need to really be thinking what we're doing next. Okay, so just putting all these bits and pieces together. We know that it's got to be more than 5 meters from the back of the house. It needs to be up in this top region here. We also know it needs to be closer to the left-hand fence. It needs to be sort of in this triangular section here. So we're looking at this triangle here, from the red line, the black line, and the left-hand fence. So we're looking at this triangular region here. However, the final piece of the puzzle, it needs to be within 8 meters from the back right-hand corner of the garden. So of this triangular section, it's got to be on this side, on the inner side of this big sweeping blue curve. And so putting all those different pieces of information together, the region we need to shade in is this bit here. I'm just going to show you in red. So take care to not go over your lines too much. I know I'm being a hypocrite because I just have. And colour in as accurately as you can and as clearly as you can, so the examiner has got very little doubt and no real option apart from to mark you correct. And there you go, that's the region we need to be shading. So that's question 5 completed. Question 6, we've got 2 towns, Burford and Hightown, and this company here is going to build a warehouse that's less than 30 centimetres from Burford and less than 50 kilometres from Hightown. I'm saying centimetres because that's going to be how we're going to represent these distances on the diagram. So using this scale here at the bottom, we can convert these real life distances to distances we can actually work with. And so 30 kilometres, in our case that means 3 centimetres, and 50 kilometres, in our case that means 5 centimetres, because each 1 centimetre represents 10 kilometres. So, because it's going to be, in our case, less than 3 centimetres from Burford, then what we're going to do is measure out 3 centimetres compass width, put the compass needle on top of Burford and do a circle all around Burford. So within that circle is where the warehouse needs to be. The warehouse needs to be within that circle. However, reading about Hightown, this warehouse also needs to be within 5 centimetres in our case of Hightown. So measure out compass width of 5 centimetres. And do a big curve all the way around like that. And so the warehouse needs to be within the big circle and within the small circle. And the only way it can be within both of those circles is where those circles overlap. And so the region we want to just put in here is going to be the region in between the circles, this bit here. And so that yellow bit is the region which is where the warehouse can be built. And so that's all we needed to do for question 6. Question 7, finally we have a map showing 2 airports A and B, and a hotel needs to be built somewhere within this diagram. So the hotel is going to be closer to airport A than airport B. If we're talking about distances between 2 points, what we need first of all is the perpendicular bisector of the line that joins those 2 points together. So if we do an imaginary line from A and B, we can then bisect that line. So first of all, put the compass needle on one end of the line. Let's say we can start with B. And a big curve above and below B. And swap sides and do exactly the same thing at A, a big curve above and below A. The curves need to cross at 2 points, and where the 2 bits where these curves cross, we find them, we do a straight line with ruler between these crossing parts here, like so. And so that red line is the perpendicular bisector of the line AB. On that red line is the barrier which separates the distances which are equal distance from both A and B. We're also told, though, that this hotel will be less than 40 kilometres from airport B. So the final piece of this is, because 1 centimetre represents 10 kilometres, we need to think how much we need on our diagram for 40 kilometres. And so 40 kilometres will actually be 4 centimetres. And so in our case, on the diagram, the airport needs to be within 4 centimetres of airport B. So if we move it in like this, we're going to do a circle centred at B, which is 4 centimetres in radius. So a big circle all the way around like this. So it needs to be closer to A than B, so it needs to be this side of the red line, but also needs to be within the big blue circle I've just joined. And the only way for that to happen is for it to be in between the red line and this blue circular curve. That is definitely not right. So again, sometimes I try these tools on my screen, it doesn't work quite as expected. So what I'm going to do here is just shade it in manually for you for the region we're interested in. As I say, it's the bit between the red straight line, which is here, and the blue curve. So without going over the lines too much, we need to just colour in the region in between that straight red line and the curved blue line. And that's it. So that's the region we're interested in, and that's 3 marks done. So that was a pretty full-on sort of run-through and tutorial about how to do constructions and loci. But just do bear in mind, in my humble opinion, they'll be fairly rare to come across in the exams. If and when you do, I don't personally suspect they'll be worth loads and loads of marks. For example, algebra can come up in all 3 papers in different forms, expanding, factorising, solving. Constructions and loci, I don't think are the biggest thing to worry about. So if your tutor hasn't gone into too much depth in lessons on these sorts of questions, this is what this video is for. It's to supplement the learning you may have had or may not have had in your lesson time. So I hope at least some of that's been useful for you. So thank you for listening, and I'll hopefully see you again sometime soon.